So chapter 3, section 4 is finding and using the slopes of lines. So in Algebra 1, you graphed lines all the time. You were graphing lines, different lines, horizontal lines, vertical lines, diagonal lines. You were graphing them all the time. But if you think about it, in geometry, we're dealing with shapes, and you've seen that there's all these lines that are coming together. So we're going to kind of combine these two ideas that, like, whoa, like if I had these lines and I put them on a graph, I would know the slope of them. Those are things that we can work with as well. Okay, so when we talk about slope, I'm not changing anything here. This is still the same stuff that you learned. First of all, your slope formula, the way you learned it, should have been y2 over y1, the differences of the y's over the differences of the x's, the rise over the run. Now, you learned that before, rise being how much it changes up or down, and then the run, if you imagine running, it's the run is how much it changes left or right. So we're talking about the y's over the x's. The slope of a non-vertical line, so it can't be a vertical line when we talk about this, is the ratio of change in y, the vertical change, to change in x. And really all what we mean in plain English when we talk about slope, sometimes we get caught up in these math definitions, is if you think about it, to go from here to here, we talk about that as the slope. How much did it change vertically versus how much did it change horizontally? If something goes up a whole lot vertically, but it doesn't change much horizontally, then that's a really steep slope there. You can see that it gets like very steep. Whereas if something changes very little vertically and it changes a lot horizontally, then that's not so steep. So you can see those changes there. So we're going to be talking a lot about those lines there. But most importantly, and you do need to know this, if you don't have it committed to memory, you must commit it to memory, that m, the letter m, which we use in math to represent slope, the formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, meaning there's two y's, you're going to go ahead and subtract the y's, and there's two x's, you're going to go ahead and subtract the x's. Now, I said this before, I'll say it again. It doesn't matter which set you call the first set and which set you call the second set, but you can't just pick whichever one you want for, like this can be x1, y1, or this could have been x2, y2. But the ones stay together and the twos stay together. You can't call, you could never call this set here x sub 1, y sub 2. That's not acceptable. The 1 or the 2 represents which set is it. You can't break up that set. Here's a set of x and y's, there's a set of x of y and x and y's on the right. Questions on that slide? All right, this is actually all pretty quick today. Most of it's a review. All right, so there's 4 types of slope that we deal with. When we're talking about a positive slope, for example, like if m is, 7/4, that's a positive number, I can tell just by looking at that, since it's a positive number, that this will go up as it goes to the right. It rises as it moves right. So we look at these from left to right, like you're reading a book. So you just look at the line, and I kind of look at it like this. As I go from left to right, it's going upward. Therefore, this is a positive slope. A negative slope, as I go from left to right, is going downward. Notice it would keep going down, down, down. A horizontal line. These are the two that everybody seems to forget here, so focus in on these. A horizontal line will go left to right. It might look something like this. Like, let's say we have the line y equals 3 would look like this. 1, 2, 3. That would be the line y equals 3. And its slope is always 0. So anytime you have a horizontal line, it is a slope of 0. For example, y equals 0x plus 3. If I have 0x, isn't 0 times x 0? Right? 0 times x is 0. So that just disappears, and we get y equals 3. That's how I know. If there are no x's there, if I don't see any x's at all, it's just y equals something, that is a horizontal line. Guaranteed. Y equals a number, that's a horizontal line. Now the other one, the one that is vertical, is not 0, it's undefined. So let's talk about why one's 0 and one of them is undefined, because there's a reason why they are. Like, why is this one 0 and why is that one undefined? How did we come up with that? This one might look like 1, 2, 3. This equation might look like x equals 3. So how did I know that this was like x equals 3? If you think about it, every single point on this line has the exact same x value, right? It's changing up and down. It's going higher and lower, but it never goes further left. It never goes further right. The x is staying the exact same. That's why it says x equals 3. I just moved it 3 to the right. That's just an example. It could have been x equals 4. It could have been x equals 27. But when it's just x equals a number, that is a vertical line. But let's talk about this. Let's look at the slope. I'm going to go here, and let's see how much it changes. It goes up 1, right? So from 0 to 1, it goes up 1. How many did I move to the left or right when I go up 1? 0. Now, one of the things that if you are not familiar with, we cannot divide by 0 in math. If you have Siri on your phone and you ask her to divide something by 0, she gives you very funny answers. You can't do it. I mean, I always give this speech every year, and I go, if you look around the room, we are a group of people. I could divide you into one group. Boom, you're one group. You're a classroom of one group of kids. And then I go, I could divide you into a group of 2. I can split you down the middle, and I can say, okay, here's the left half of the room, the right half of the room. I could divide you into a group of thirds or fourths. But what I can't do is divide you into a group of 0. You might be like, yeah, just don't give us a group. Well, you're still a group of 1. I can't change that. You are a group of 1 right now. I can't make you a group of 0. I can't make you not exist. You exist, you're here, so it is a group, and I can't divide by 0. Whereas this one, when I did it, I can go right 1 and up 0. Up 0, right 1. Up 0, right 1. Up 0, right 1. Up 0, which when I work that out, 0 over anything becomes 0. So that's the reason why 1 is 0 and 1 is undefined. If 0 is in the denominator, that is undefined. We can't calculate that. Okay, so we talked about steepness. Like when we talk about steepness, we're really just talking about, imagine a mountain. You know what I mean? It's like, given the choice, you're going to be one of 2 kind of people. You might rather walk up this hill because you want a nice, easy path, or you might be the kind of person who likes a challenge, and maybe you would like to walk up this path. But their steepness is different. The one on the left is much steeper. So when we talk about the steepness of a line, we're talking about the greater the absolute value of the line's slope, the steeper the line. So what it means is that if I have a slope of 2, that is not as steep as a slope of 4. So if I had to guess, like actually that line's really steep. That's really steep. If I had to put these somewhere, I would say that the one that's really steep, the one that is 6, is probably there, and the one that is not so steep is right there. I'm just making those numbers up. I'm just showing you that the lower the value of the number, the absolute value of the number, the less steep it will be. But that includes negative numbers too. Like if you imagine falling down this hill would be very steep. Falling down this hill would not be that steep at all. But this might be, the slope is -8. And this one, the slope might be -2. But if you take the absolute value of those, this one still has 8, still has a greater absolute value, so it is the steeper one. If you want to know which one is steeper, we just look at the absolute value of their lines. The greater the number when we do the absolute value, the greater the steepness. Okay, so our next postulate is the slope of parallel lines postulate. In a coordinate plane, that means our xy axis on where we're actually graphing. That's what we're talking about there. So when you hear the words coordinate plane, you're going to imagine that we are talking about actually graphing them. Like if we were to graph these things. In a coordinate plane, 2 non-vertical lines. So any 2 lines, but they can't be vertical lines, non-vertical. They can't be vertical lines. They're parallel if and only if they have the same slope. So let's say that I'm looking at a graph and I see 2 lines here. So I'm going to draw a really poor graph here because I don't have one available. So I go, let's say that I see 2 lines and I am asked to determine whether these 2 lines are parallel. Then it's not about whether they look parallel or not. It's about their slopes. if they have the same slope, then they are parallel. So I'm looking at two lines, I would need to calculate that. If their slopes are parallel, if their slopes are equal, then they are parallel. So it doesn't matter whether those lines are going positive or negative, but remember, all I would need is some points. If I had 2 points on here, I could figure out what the slope is. If I had 2 points on here, I could figure out what the slope is. If the slopes are exactly the same, then they are parallel. Question on that? Okie dokie. We got to move quick because we only have like 15 minutes left today. The slopes of perpendicular lines. This is the one that people mess up. So I'm putting a star in it there because I'm trying to tell you if there's going to be a mistake made, it's probably going to be made on this one. In a coordinate plane, so when we are graphing these, two non-vertical lines are perpendicular. So now we're not talking about parallel, we're talking about perpendicular, and perpendicular means that these two lines form what?
90-degree angle.
90-degree angle. They form a right angle. So they are perpendicular if and only if the product of their slopes is -1. It means if you take the two slopes and you multiply them together, you will get -1. But I'm going to show you a much easier way to tell whether things are perpendicular or not. So let's say that I have a slope of 3. One of my lines has a slope of 3. And the other one has a slope of -1/3. I can tell just by looking at those numbers, no picture, nothing, whether they are perpendicular or not, because I could multiply those two things together. Now watch this. I'll go 3 times -1/3. If I were to multiply those together, it would look like this. 3 goes into 3 ones, 3 goes into 3 ones. This is going to equal -1. So with those two slopes, these lines that have these two slopes, would they be perpendicular? Yes, but think about it like this. Here's an easier way to think of it. If you don't want to do any math, all I'm thinking in my head, I don't actually do any math. That's not how I calculate it. I don't actually do that. I look to see whether these two numbers are opposite reciprocals. Oh, sorry. They're opposite reciprocals of each other. So, and what I mean by opposite reciprocal, when I say opposite, it means opposite sign. One of them is positive, opposite sign. One of them is positive, one of them is negative, which I do have. They are definitely opposite signs. And reciprocal means that one of them is the flipped upside down version of the other. 3 and 1/3 are the flipped upside down versions of each other. If I take 3, which looks like this, and I flip it upside down, what happens is it becomes like this. So they have to be opposite reciprocals. So you can do the math if you want, but what I'm doing is just flipping it upside down and go, oh yeah, those definitely are. So what about 4/3? What is the opposite reciprocal of 4/3? -3/4. If two lines had these slopes, they would be perpendicular, guaranteed, because they are opposite reciprocals. So you could find the line very easily. If I said which slope, what is the slope of a line that is perpendicular to this slope, then you would be like, oh, just take the opposite reciprocal. Take the slope, flip it upside down, and change the sign. Opposite signs, reciprocals. Yep.
So this works for every time you're trying to find if it's perpendicular?
Right, if they're perpendicular. So perpendicular, it always 100% of the time means that their slopes are opposite reciprocals. It does say non-vertical lines though, because when we flip the 1/0 there, like we actually get something we can't calculate. So we have to be careful with that. Non-vertical lines. So we have to make sure they are non-vertical lines. It's the one scenario where we get some weirdness. All right, let's place them always, sometimes, never. The slope of a vertical line is always, sometimes, or never 0. Never. Remember, the vertical one is undefined. The slope of a horizontal line is always, sometimes, never 0. Always. The slope of a line that rises to the right, that means as I'm looking at it from left to right, it is rising, is positive. Is that always, sometimes, or never true? Always. The slope of a line that falls as it goes to the right is always, sometimes, never negative. Always. What you mean? So she's asking, are you not supposed to count the slope as negative? When we talk about the absolute value, we're talking about how steep it is. Yeah. So think about there's two mountains, right? Like one of them, I could be at the top and it's very steep because I could fall down it. That line is going downward. That's a negative slope right there. It's still steep. I'm at the top. It would be dangerous for me to fall down. That is a negative slope, but very steep. It means that its absolute value is a great number. It's a big number. Whereas I could be standing at the bottom of a mountain, and I'm looking up it, and I can go, man, this is going to be hard to climb because this is really steep. It goes like straight up. That is also a very steep line, and it has a positive slope. So it's okay. Definitely slopes have positive or negative numbers, but when we talk about the absolute value, we're talking about how steep is it. So like walking across this room, this floor has a slope of 0. It's horizontal because it's very easy to walk across. If the floor had a slope of 17, it would be very difficult to walk across the room. Okay, so we're going to find the slope of the line that passes through the 2 points. Now remember, if you don't have it written down, you're going to want to rewrite that formula, which was the slope formula. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, again, I am going to go to A there, and here's an x, here's a y, here's an x, here's a y. Just to show you, I never do it this way, but I want to show you that it doesn't matter even if I switch it. I'm going to call this the second set and this the first set. I don't ever normally do it that way. Normally I would do it the other way. I would call because I read left to right, I would call it x1, y1 on the left and x2, y2 on the right. But I want to prove to you that it doesn't matter. It doesn't matter. Just call one of them set 2 and one of them set 1. And now we can do this formula. So y sub 2 is 4. Minus y sub 1 is 5. Over x sub 2 is negative 3. Minus x sub 1 and negative 1, x sub 1 is negative 4. Now, you have to be careful. It says to subtract them. So if you are subtracting a negative number, don't disregard that there is another negative there, because look at what's going to happen in the bottom. That's going to become positive. 4 minus 5 becomes negative 1, and negative 3 plus 4 becomes a positive 1, meaning that this slope is negative 1. Give me a general idea. That line right there, the line that passes through these 2 points, is it going up and to the right, or is it going down and to the right? Down and to the right, because it has a negative slope. Is it a very steep line? No, not very steep at all. It's got a slope of 1. It's a pretty low number. It means not very steep at all. So if I had to guess, it probably looks something like this, and that might even be too steep right there. It's going downward like that. All right, let's do one more. I don't want to do all these. I'm going to jump to the very last one here. And I'm going to do this one, x1, y1, x2, y2. Why did I switch? Just because it doesn't matter. It doesn't matter. Just call one of them the first set, the other one the second set. I don't want you to get hung up on which one is the first set and which one is the second set. That part doesn't matter. Just make sure that you don't you couldn't do this. You couldn't call one of these things x1 and the one right next to it y2. This is a set. So it's set 1, there is set 2. We could reverse the numbers on these and be just as good. So y sub 2 is 9 minus y sub 1 is negative 2. X sub 2 is negative 6 minus x sub 1, which is negative 6. So here we go. 9 plus 2 is 11. And then negative 6 plus 6 is 0. Ooh, talk to me about that one.
It's undefined.
It's undefined. We can't calculate that slope. What does this line look like? Straight up and down. Now, I don't know where it goes straight up down. Actually, I do. I can tell you right now, the fact that they both go through negative 6 tells me that this line is right there at negative 6 going up and down. The fact that, think about it. If it goes straight up and down, it must be hitting the same x over and over again because it's going straight up and down, so it must be at negative 6.
Okay, I don't know if this sounds funny, but how do you know which lines are vertical and which ones are horizontal?
So if the slope is undefined, that was the slide that we did back there, then it is a vertical line. If the slope is 0, it's a horizontal line. That was like the slide or two back from us. Yep.
All right, so I know I'm going to sound really dumb asking this question.
By the way, you guys have really good questions, so don't worry about it.
This one's not good. Okay, so I calculated my slope, and the denominator was negative. So can I just move it to in front of the fraction?
Your question is not dumb. People ask this question all the time. Here's her question. She's got this scenario. She did her math on, which one was that? The second one?
The second one.
The second one. She ended up with this in this scenario. 1 over negative 7. And she's saying, is that the same thing as this? Yes, it is, and it's also the same thing as this. All of those are exactly the same. Now, here is what is not the same. This is not the same. Why is that last one different?
Because two negatives equal positive.
Because two negatives would end up positive. All the top ones end up negative. This one, a negative divided by negative, would be a positive. That slope would look totally different. That is not the same thing.
Okay.
Yes, sir?
But I thought denominators can be negative.
Denominators can be negative. Yeah, but like you can have negative numbers. It's really just the whole, think about it like this. Like we talk about the numerator and the denominator, but like 1/2, if I say, can I have half of that pizza? In your brain, you're not separating it into a numerator and a denominator. You're like, it's half. You know what I mean? That's a number, 50% of it. So like when 1/7, it's a decimal as well. It's just, this is a positive number. This is a negative number. Like if you did it in your calculator, if you did -1 divided by 7, like let me just go real quick and give you an idea here. Like if I go -1 divided by 7 gives me -0.14287 ... It keeps going on and on and on. So I go, that's a number. It's just a number, that's all. Whether I put the negative at the top or the bottom, it's the same number. It's one whole number. It's just showing you it's like two parts of the thing, two parts of the number there. Okay, so now it says complete the table for when R is parallel to S and R is perpendicular to S. Complete the table for R is parallel to S and R is perpendicular to S. Okay. Is mine missing something here? I don't see where I'm supposed to put my parallel or my... I'm just looking at something here. I'm sorry. I didn't read the instructions. Okay, because I was like, wait, what am I supposed to do here? So for S, when I plug in S, I want the one that is parallel. So like here they gave me R. I need to know if R is parallel to S. If R is parallel to S, what is true about their slopes? They have the exact same thing. R is parallel to S. They have the exact same thing. And in every section of this, I know that R and S, since they are parallel, then what will be true in every situation about R and S with their slopes? They're the same. So look here, R and S right there are the same. R and S right there are the same. Now the other ones, I don't have R and I don't have S, so I can't do that. In the other ones, they said R and T are perpendicular. If two lines are perpendicular, then what is true about their slopes?
The opposite reciprocal.
Perfect. So if T has a slope of 1/6, then what is the opposite reciprocal of 1/6? -6. So if S is -6, then what is R? -6, same thing. Okay, so don't be stumped by this. Do not let this throw you off. You know what you're doing. Just do the rule. If the slope of T is A, then what is the slope of S? Okay, it would be negative what?
-1 over A.
-1 over A. If this one is A, think about it as a fraction, A over 1, then its reciprocal would be 1 over A, and its opposite reciprocal would be -1 over A, meaning that the slope of R is -1 over A as well. Let's impress me. What is the slope of S for this line? And what is the slope of R? Beautiful. Sometimes I'll spend as much as 10 minutes on this slide, and you guys nailed that in like a little over a minute. Okay. If R is parallel to S and R is a horizontal line, let's talk about R. If R is a horizontal line, it's horizontal. What is its slope?
0.
Its slope is 0. So R and S are parallel. So what is true about their slopes? They're the same. So what is the slope of S?
0.
Okay, so its slope is also 0. So most of these are pretty quick. And I think our next one will probably have 1 minute. We're just going to get it really quick here. I'm guessing it's going to say this thing. If K is perpendicular to N and N has a slope of 0. So here's line N. Its slope is 0. Then what is the slope of K? Tell me about line N. What kind of line is it? It's what? It's horizontal. So what about K? What kind of line is K? It's vertical. So its slope must be, as you said, undefined.